Hey everyone, so today we are going to answer this question. It's interesting and also it's a chance to have a little chemistry class. So grab your notes and let's enjoy it. So what is a hydroxy acid? Hydroxy acid is any organic compound that contain the two functional group, the hydroxy group, the OH, as you can see here, and the acid group, which is also called carboxylic group, which is the COOH. So any compound or any hydroxy acid must contain those two functional groups. But what is the difference between alpha and beta? We have here two examples. Here on the right we have alpha, on the left we have beta. The only difference is that how many carbons those functional groups are away from each other. So in the case of beta hydroxy acid here, the acid group is 2 carbons away from the hydroxy group. So it's basically alpha carbon, beta carbon away from the acid group. So it's a beta hydroxy acid. On the right, we have the alpha hydroxy, which is the acid group is only 1 carbon away, which is alpha, from the hydroxy group. So it's an alpha hydroxy acid. Now to the main point why salicylic acid is not a BHA, technically speaking, but in general, it's known as a BHA. If we follow the same naming rule from the previous example, the hydroxy group is 2 carbons away from the acid group, 1 alpha, 2 beta, and here is the hydroxy group. But in a way, those are not technically connected through 2 carbons. They are connected through an aromatic carbon, aromatic ring, as you can see here, and a benzene ring. This is affect the way that those 2 groups interact with each other. So physiologically speaking, salicylic acid on the skin does not act in a beta hydroxy acid way as a beta hydroxy acid expected to act. Another reason is that in those 2 or 3 examples here, the OH group in alpha hydroxy acid, beta hydroxy acid, and polyhydroxy acid usually stay neutral. The only action of the acidity is the carboxylic group here that gives the, let's say, the acidity of the acid. But in salicylic acid, due to the existence of the benzene ring, the aromatic ring here, this interaction is different. So the OH, the hydroxy group, and the acid group, the COOH, both shows acidic behavior, gives the salicylic acid a acidity function. So those are the main reason why we cannot consider technically again salicylic acid to be a BHA.